The following presentation is for NEXIO's BAT-EMC software. In a previous presentation, we explored the radiated emissions test according to the CISPR standard. In this presentation, we're going to show some additional aspects regarding radiated emissions testing under the topic of workflow. In that previous example, I showed an initial test that was done to Class A, and I showed how we could do a duplication and make a comment stating that we added a power cable, such as if we were investigating a disturbance. And the same goes for that example. Let me do yet another example, and I will duplicate this. I'm going to change the name, and I will write Prescan only. Select OK. Now I will click on this subrange, and for the procedure you can see that we had the pre-scan for doing the maximization, and later on we would filter it, look for a certain number of highest peaks, and then do the final scan with the full maximization, antenna height, azimuth, etc., and then do a final measurement using the quasi-peak rather than the peak detector that was done in pre-scan. Now, if it is a qualification run and the investigations are over, then it makes sense to do the full test on the peaks that you found. However, for the interest of time, during an investigation, it would be a good idea just to complete all of the pre-scans and then decide if extra time was needed to do the final scans. If there weren't any failures, then there's no need to spend a great deal of time maximizing and then measuring with the quasi-peak detector, obviously. So we will do away with those, and I will show how they could be done later. Once again, full azimuth, full height, not necessary at this time. Okay. Now, when I run this test, it is only going to be doing the pre-scan. Then I would start the test, and it will carry on. It will go through all these subranges, but it's not going to do any final test. I'm going to stop that, and I will show yet again another time savings for investigation. I can duplicate, and I will change the name to 1 meter fixed height. State OK. And why would this be the case? Well, this is another thing we have heard from many test labs, is that in investigation mode, the majority of the time the disturbances are higher at the 1 meter height anyway. And so I can further speed things up by changing the pre-scan to only measure at 1 height. How would I do that? Allow me to delete that. Delete that. I will only add the continuous rotation from 0 to 360. And I can select OK. To make things easier, I can export this particular routine. I will call it azimuth only. And then for each one of these subranges, we will do the same. One of the added advantages of having a procedure to import is uniformity and consistency. It is very easy to add or change a parameter by accident when we are in a hurry. Now, if I click on each one of these, we will set the height to a fixed height. There we go. Let's just verify each one of those settings are correct. Now when I execute the test, you will note a similar dialog box, but there will be no changing of an antenna height. You'll note all we have is the changing of the angle. Okay, we'll let the test continue, and I will pause while the test carries on and then restart when it's toward the end. Now, as you can see, I'm on the last sub-range and we are getting near the end. The peaks were marked according to the advanced suspects. If I were to click on this tab, you can see that we have all of the pre-scan data here, individual tabs for quasi-peak and average. And let's say if I were to be in this sub-range for horizontal and I wanted to run the finals, but I didn't want to do finals on everything, I just wanted to do finals on that, I could right click on that, state to recalc finals, and I will say advanced finals. The previous routine that was saved is right there, and now I can just run the finals on the single frequency. It's going to do the 0 to 360 continuous as well as the 1 to 4 meter height. Now it's incrementing in height. It is being commanded to return to the location where the maximum value was found for the height. And there you have it. You have a final measurement. Another thing that could have been done, for example, if we wanted to investigate this peak further, you could click on the peak. We will use this cursor, right click on it, select cursor 1, transfer to table of suspects. Then I could run the advanced finals on that. So as you can see, there's a great deal of flexibility built in. Please be sure to check out the other video on the Maxwell manual measurement mode, where all of this can be used to center on a peak, maximize the antenna height and the azimuth, then do a final quasi-peak measurement, or for the case above 1 gigahertz, CISPR average and peak. I will close this, and this concludes the workflow section, or the options of how investigations can be done versus qualification runs, and how you can defer the measurement within a individual sub-range. One thing else to show you, if I were to click at this level, is that we have a global procedure, in which case all of the pre-scans would be done, and rather than doing a what would you call the advanced finals per subrange. In this case, by clicking at this level and clicking on global procedure, you could be having routines for each one of these. Data reduction and finals. The difference being is that it would do all the pre-scan, and then finally, once the pre-scans are done, it would execute the final measurements. This concludes the NEXIO presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.